Hello, so welcome back to the next session of the LIPES workshop. The coming session will now be dedicated to the life cycle analysis and the key performance indicators, the KPIs, of the enzymatic process. And for this, I will hand over to Peter Strudens from Oleon. Peter, the floor is yours.
Thank you, Jan.
Yeah, I can see your presentation.
Okay, thank you, Jan, for the kind introduction. I hope technically everything is okay. And thank you for watching this video. My name is Peter Strudens and I work as an R&D manager for Oleon. In this short video, I will be presenting what LIPES means for Oleon, and I will be discussing some project KPIs and LCA studies we did. But first, some words on Oleon and oleochemistry. Yes, Oleon is an oleochemical company. This means we transform vegetable oils and animal fats into valuable chemicals. Valuable chemicals you will encounter in many aspects of your daily life. Together with our dedicated sales, our flexible and big production units, and our R&D department, we serve many markets, such as, of course, the usual suspects, lubricants and detergents, but also nutrition. Think on emulsifiers, biodiesel methyl esters, polymer additives, and other oleochemical building blocks, but also crop protection, oil field chemicals, coatings, and cosmetics. It is clear if you look around you, you will see oleochemicals everywhere. And further, oleochemistry is actually not very new. In fact, we are using quite established technology. Many years before people were even speaking of biorefineries, we were already doing it. So, almost 200 years ago, Oleon started as a candle factory, making candle waxes from animal fats. In the second half of the previous century, Oleon was part of a Belgian petrochemical company, which became later part of the Total Group. In 2000, Oleon was sold to an investment group, and 9 years later, the French agro-industrial group La Groupe Avril acquired 100% of the shares of Oleon. The vision of Oleon is to become a leading global provider of oleochemical building blocks and solutions to our customers worldwide by focusing on customer intimacy, innovation, and sustainable development, while providing our employees with a safe and stimulating work environment. As I said already a few minutes ago, Oleon is part of the French Avril group. Avril is French for the month April. This La Groupe Avril is built around a value chain in the oils and protein sector, which will be presented in the next slide. On the right-hand side of this slide, you can already see some proprietary brands names from the group. But here the value chain in which this group is built, is founded. So the group was founded by 100,000 farmers in France. Their value chain starts in the upper left corner of this slide. In this group, we have companies optimizing and producing oil seeds that are used subsequently by the French farmers. So once the crops are grown, the oil seeds are collected and sent to our own big crushing plants. And when you crush oil seeds, you have two outlets. One, the oil side, and on the other side, you also have the protein fraction. From the protein fraction, mainly animal feed is produced. Also some chemistry is done, but animal feed is the focus, with even very specialized feeds that are being produced. This goes back to the farmers, livestock is grown, The livestock is then brought back into the group where slaughterhouses and meat producing factories transform the meat into meat for daily consumption. But let's focus now on the oil side. So the main outlet for the oil is, of course, human consumption. In our daily diet, we need triglycerides, but also biodiesel can be made from vegetable oil. And last but not least, you can also do some very nice chemistry with it. And this is, of course, where Oleon steps in. Further, for Oleon, corporate social responsibility, or CSR, is a very important aspect in our company. As guidelines for our CSR policy, we use the United Nations Sustainable Development Goals and focus on 5 goals in particular. First one, affordable and clean energy. A nice example on efforts we do within Oleon is, for example, the installation of a large CHP unit in our Erdvelde factory. Second, decent work and economic growth. A nice example here is a code of conduct that we have implemented for our suppliers. Next goal, industry, innovation and infrastructure. Here is a target we set ourselves, for example, in R&D, where we make sure that all newly developed products comprise at least 80% of renewable materials. Goal number 12, the responsible consumption and production. Here we do a lot of efforts to make sure that all our palm oil that we use in our processes is traceable. Since 2017, we can guarantee 100% traceability of our raw materials. The last goal, goal number 13, which we focus on, is the one for climate action, where we focus on consumption of energy and wastewater treatment. And this is the goal where the LIPES project fits in. In this project, we are reducing waste and energy consumption drastically for one of our processes, on which I will elaborate in the next slides. But to elaborate, I have to speak again a little bit about oleochemistry. So in this slide, I want to give you a short overview on what we do in the oleochemical business. And of course, like every good story, it all begins with the flowers and the bees and the oil seeds as a result. So the oil, or better triglycerides, are produced from the seeds, and this is the point where the oleochemistry starts. The oil is hydrolyzed into a fatty acid and a glycerol fraction. Both fractions can undergo several purifications, fractionations, and transformations to a wide range of specialities. Further, the acids and alcohols can be recombined into esters, resulting in virtually unlimited combinations and applications. In the LIPES project, we focus on hydrolysis technology, or the splitting of the oil or the triglycerides into fatty acids and glycerol. So let's focus now on this hydrolysis of the triglycerides, or fat splitting, as we call it. As you can see here on the slide, a triglyceride is hydrolyzed by means of water, yielding 3 fatty acid molecules and 1 glycerol molecule. This can be done either via soap splitting, as shown on the left, but industrially, the Colgate-Emery process, which is a pressure hydrolysis, is well established. In this process, triglycerides, or the oils, are injected in a column together with water and steam at high pressure and temperature. As you can see here on the slide, 60 bars and 260 degrees Celsius are applied. By doing so, the triglycerides are split into the acids and glycerol. And because of the density difference, the acids can be extracted at the top of the column and the glycerine at the bottom. This process works actually very good with only water and vegetable oil, but it must be clear that this process requires quite some energy, as these high temperatures and pressures are required. And it was in this slide that the LIPES project was born. So within our labs, we had developed a new process for oil splitting by means of enzymes. In this process, enzymes do all the work, but at very moderate reaction conditions. And the goal of this project was consequently to scale up this process to a pre-industrial level, so that means to demo scale, and proving the cost competitiveness compared to a traditional hydrolysis process. So as I said in the previous slide, when hydrolyzing oils by means of enzymes, or better said lipases, very moderate reaction conditions are applied. No pressure is needed and only 35 degrees Celsius is sufficient. Because of these moderate conditions, less energy is required, resulting in more sustainable or greener fatty acids. Further, since the low temperature, also no thermal stress is acted on the acids, resulting in fatty acids without trans fatty acids. So these acids with no trans fatty acid, and because of the moderate conditions in which they are produced, they show a better quality. So they have a better color stability, and they have a better smell. So this makes this product excellently suited to be used in food and personal care markets. Furthermore, because of the enzymatic technology we used, certificates such as certified organic are possible. But let's focus now on the project KPIs. So within this LIPES project, we have set ourselves some targets, which we monitor by means of KPIs. The first one is water. We all know that water is a valuable resource, so we want to recycle our water at least once in the process. So far, we have managed to recycle it 2 times in a row. Also, the water consumption per ton is an important KPI. With the LIPES technology, the water consumption was more than halved, which is a very good result. For the electricity use, we did not reach our target, unfortunately, yet. This is mainly because the equipment we use on our pilot installation are a bit over-dimensioned, and we use, of course, the power that is specified on this equipment. But at the moment, we are working hard to improve this and also to get this KPI in target. For the trans fatty acids, we have really proven the benefits of this technology, because no trans fatty acids were found in the fatty acids coming out of this LIPES process. We do not only follow up KPIs, but also perform life cycle analysis studies, or LCA studies, on this LIPES process. We do this in-house according to ISO standards, ISO 14040, ISO 14044, and ISO 14067, and use a cradle-to-gate approach, both for the production of oleic acid, the fatty acid, and glycerol. As a software, we use CIMAPRO and EcoInvent and AgriBalise databases to calculate the footprint. So for this study, we took into account the oil hydrolysis, followed by the purification of the fatty acids, as well as the purification of the glycerin. When we did this on the vegetable oil splitting part, with the data we have so far acquired in the project, we have seen that we can reduce the amount of CO2 equivalent per ton of hydrolyzed oil, that we can reduce it from 49 kilograms to 24 kilograms. This means a reduction of 51% in carbon footprint, which is, of course, a great achievement. Also, for the glycerin side, a very nice reduction was observed. We managed to reduce the CO2 equivalent per ton of glycerin from almost 190 kilograms per ton to 118 kilograms. Again, a reduction of 38%. So when we look at this globally, so if we consider the entire process, starting from the oil and water splitting into fatty acids and glycerol, and the subsequent refining of the acids and glycerin, we have demonstrated so far a reduction in CO2 footprint of almost 48%, which is a fantastic result. So to conclude, it is clear that the LIPES project helps Oleon in its transition towards an even more sustainable and natural way for producing chemicals. And it is clear that with this technology, with less resources, less energy, less water use, less waste generation, less carbon emission, we can make products, we can make fatty acids that are more green, have more quality, are more stable, and are more healthy products. And with this statement, I want to conclude and thank you for your attention.
Well, thank you, Peter, for this interesting speech on the LCA and the KPIs data of the LIPES project. I've got a couple of questions for you. The first one, in the process you describe, the glycerol core product has a much lower carbon footprint. Can you explain what are the reasons for that?
Yeah, we have a very good reason for that. This is also one of the major difference between our traditional process and the enzymatic process, being that the glycerol that is produced after splitting, the glycerol water more in particular, has a higher glycerol concentration. This means less energy is required to remove the water from the glycerol because there is less water present, resulting in a footprint reduction of 38%. So this is also a big advantage of this technology.
Okay. And also you mentioned the KPIs for energy and enzyme recycling. How do you plan to meet the targeted KPIs by the end of the project and to meet the gap between what it is now and what we expect it to be towards the end of the project?
That is true. So some of the KPIs we have presented, we are not there yet, we admit this, but these are KPIs that I'm sure that will have better values, better results on our large demo reactor, which was on which we are experimenting as we speak. So we have to wait on these test results, on all the tests we do on our demo unit to have a good view on these KPIs.
Okay. Well, thanks again, Peter, and thank you all for watching today. Don't hesitate to leave us a comment or questions if you've got any, and we'll get back to you as soon as possible.
Thank you.